So please welcome Victoria Livschitz from Qubell.
Good morning. Whoa. It's a pleasure to be here today and talk about DevOps, talk about automation, and talk about what industry have accomplished in maybe 5 years of working on what today is known as a DevOps, and where the industry is going. I don't suppose many of you know about Qubell yet. We are an enterprise DevOps company, and we come at automation from a very particular point of view. We believe that at the core of system that manages application in its life cycle is the understanding about configuration of that system and all of its elements. So in a nutshell, what Qubell does is collects a lot of information about an application and what does the application talk to and what it consists of and what are all the services that it connects to and what are all the dependencies that it has from the infrastructure in which it runs. And if you have all that data, then you actually can reason about what happens when the application state changes. Anything from launching another instance of the application or upgrading or updating or scaling or rolling something back. What I'm going to talk about today is happening in the context of an enormous pace of innovation that is sweeping industries and geographies and bringing the kind of change in terms of software eating the world, to use a famous phrase, that we have never seen before. A recent survey of world the largest CEOs of the largest retail companies come back with the interesting result. Fairly anonymously, all these CIOs said that their number one fear looking into the future is how quickly their industry changes. And they said that they believe that the next 10 years will bring more change than the previous 50. Internet continues to change how people communicate, shop, learn, vote, entertain, order food, receive medical services. It disrupts industries that have gone virtually unchanged in terms of their business models, sometimes for centuries. Universities, retail shops, doctors' offices. And these companies are now in the software business. And they are living and dying by the mottos of the high-tech industry that they are not familiar with and not necessarily equipped to deal with. And that change of software eating the world is pretty much touching everybody and all of you sitting in this room. There are three main parts to my talk today. I'll start looking at large corporations, particularly from a non-traditional high-tech industries, the elephants, so to speak. And they must become so much more dynamic, so much more agile, so much more experimental and innovative than they've ever been before. And they are going to fundamentally change how they develop software and how they operate software and how they manage software. They need very short feedback loop on the ideas, experimental approach to what-if scenarios, be able to iterate over many concepts and ideas very quickly in small increments. And that, again, requires the kind of capabilities that they are in the very early days of constructing. And the role of the automators, companies like mine and the rest of the vendor industry is here to make it easy, or at least to make it doable for them. And then I will talk about innovation increasingly becoming an industrialized process. Software operations of these big companies essentially have to become agile software factories, and they have to build this conveyor belt that runs through their software operations. And on one side of the conveyor belt, developers are committing code changes. And on the other side of the conveyor belt, those code changes are getting deployed into production. And every facet of that conveyor belt is automated with respect to testing and verification. And in order for those conveyor belts to be operated, there has to be a just-in-time assembly of infrastructure, applications, data sets, components, access points, which all get sort of constructed on demand to support the business operation that is happening on that conveyor belt at that point in time, which itself requires a supply chain of information, bits and bytes. Again, from the infrastructure to the services, to the securities and policies that tie all of these things together, network, storage, all these things have to get provisionable and controllable by software. I call that kind of computing purpose-defined computing, because a computing system essentially emerges to satisfy the business need. And we'll look at some principles of this just-in-time assembly of bits and bytes and resources and access rights that has to take place in order for these conveyor belts to work at scale. And finally, we will look at the people who are in charge of all of that innovation, the developers. The number of software that needs to be written already far exceeds the number of developers in the world who are able to write that software. And that gap is going to continue to grow and get wider, which means that the world's needs of software cannot be covered by brute force. It can only be covered by higher productivity of the software developers and people involved in the software production. And that comes back to tooling. And that comes back to, if we give them the kind of automation that we are talking about, wrapped into convenient self-service interfaces, that will supercharge productivity of our engineers. Let's kind of take a little bit of time today to take a look at how that might work. So let's begin by looking at what it takes to make elephants to dance. Large organizations are in the quest to become more agile. It is one thing for a startup to be agile, to pivot, to iterate, to try things and see if it works. Likewise, innovation in some sense is easy for massive web companies. Google, Amazon, they have built an enormous delivery machines capable of pushing hundreds, sometimes thousands of changes a day to production systems and see how market reacts to it and be agile and experimental about that. Not only are they agile and experimental, but they have extremely sophisticated analytics machines that can gather a tremendous amount of information about how customers react to the new features that are being exposed to them, and then make product decisions about the direction of the product based on the results of that analytics. But what about the rest of the world? What about the pharmacies, the banks, the manufacturing companies, logistics companies? They don't have the muscle, the capabilities, the capacity, the sophistication of the Googles and Amazons, and they have enormous body mass, if you will. They have legacy systems, legacy processes, legacy people, legacy architectures, and yet they are forced to compete. They're forced to compete with Amazon, they're forced to compete with Google, and they're forced to compete with startups that are coming left and right and are taking every inefficiency of the market. If you're a retailer, then think about it. Next time Apple releases a new watch, you have to integrate with it almost instantaneously. If the customer cannot walk into your store and get that integrated experience, he'll walk somewhere else where he will. Now, what's interesting about this moment in time is 2014 seems to be a watershed year for the understanding of the significance of that agility in business terms, in terms of the executives of the companies. Survey after survey of CIO priorities this year have come back, and it put agility and shorter cycle times at the top of the list of the CIO priorities. And it was nowhere to be found in the top 10 list even a year ago. With everybody wanting to go fast and reduce cycle time and be more agile, why is this so hard? I believe the principal core conflict is between speed of innovation and stability and controls that are required in operating environments. This is a philosophical divide, this is a cultural divide, but this is very understandable where this comes from. Developers are supposed to try things, they're supposed to experiment these things, and they're supposed to break things. And be able to do that quickly, to iterate quickly, to loop quickly, essentially what makes them successful at developing software quickly. On the other hand, operational folks are responsible for uptime. Their mission in life is to make sure that nothing breaks. And the way they know how to do that, traditionally, historically, over decades, is to prohibit change from happening. Change is seen as risky, dangerous, and harmful to the systems. And they're right about that. Somewhere between 60 to 80% of all production outages tends to get traced to configuration changes. So when we look at what needs to change, is we need to find a way in which we can do innovation and experimentation at scale and change things in production extremely quickly, and do so without sacrificing stability, reliability, and production controls. Now, I would argue that DevOps movement, if you will, have started in the earnest right around 5 years ago, maybe in 2009. And what I would call is DevOps 1.0 didn't really address heads-on this cultural divide. In fact, it kind of worked around this. Since developers couldn't get operations folks to give them what they need, very quick access to environments, ability to get their hands on the hardware, configure and set the hardware quickly, they said, well, then we will help ourselves. Thank you very much. There is a cloud that's emerging here. And Amazon entered enterprises not through the CIOs. It entered enterprises through the line of business, where developers said, I'm getting myself a computing, I'm getting myself some open source tools, I'm getting Chef, I'm getting Jenkins, I'm good. And that put IT in a very, very, very bad spot. Essentially buried under avalanche of change requests they cannot satisfy. Blame for being the force that slows down the train. And yet responsible for catching these releases that are coming from the development organization, being responsible for deploying it, being responsible for operating it, knowing full well that the people who did all that development on their own terms don't really understand operational concerns and have never tested it on the certified configurations. All that kind of bred mistrust and blame, and in some sense didn't really help solve the problem. What seems to be happening now is an attempt to correct it, but not by embracing this cultural divide, by essentially IT recognizing that they have to be the leader, and they have to give developers what they need, but do so without sacrificing governance, efficiencies, and control. How exactly that works, I would like to illustrate by a scene of an old movie.
I am out here for you. You don't know what it's like to be me out here for you. It is an up at dawn, pride-swallowing siege that I will never fully tell you about, okay? Help me. Help me, Rod. Help me. Help you. Help me. Help you. Help me. Help you.
So hopefully ops folks in the room can relate. Jerry is the ops guy who spends restless and thankless nights trying to close the tickets to support and satisfy his impatient starts of the show, the developers. And he needs help so that he can help engineers to get what they need and what they want. To help shed some light into how that dynamics play itself in a real world, I'd like to invite my first guest, Executive Vice President of Innovation at RingCentral, Kira Makagon. Yeah, come over here.
Good morning, everyone.
Kira, thank you very much for coming.
Oh, okay, thank you. Thanks for having me. I guess you want me here?
When she talks, can you hear you?
Hello?
Yeah, that works.
Okay, I'll sit.
All right. Kira, tell us a little bit about RingCentral.
So RingCentral is a cloud provider of phone systems. We are the leader in our space, and we offer integrated voice, text, fax, high-definition video, high-definition interaction in the cloud. And essentially what that means is we are a software-as-a-service platform that offers a suite of applications, and you can run these applications on your desktop, on your mobile phone, on your tablet, and it also enables your actual desktop phone. So the system is seamlessly integrated throughout your endpoints with ease of administration and ease of deployment. And we pride ourselves on both that ease of deployment and ease of administration. We today serve over 300,000 customers in America, Canada, in North America, and UK. And these customers vary from very small to very large.
So this topic of agility, shorter release cycles, experimentation, how important is it to your company? And can you, in simple terms, make a connection between ability to have manageability and automation and business impact?
So it's very important, obviously, for us as we want to enable our customers to get the benefit of our system and the benefit of our innovation as fast as possible. We want to take our products to market as fast as possible. It takes a lot of iterative cycles to get a product to market. And to be able to do that effectively, you need that speed of environments for developments to sustain lots and lots of projects and lots of different environments that can be brought up and put down with ease of use. And that ease of use really means we don't want to run, we don't want to deploy test environments and involve a lot of operational cycles. Operations should focus on operations, and developers should focus on development. So ability to do that, and ability to do that in our own cloud, in a public cloud, is key to our success.
Our companies have been working together now for quite some time to give your teams a single button experience to provision dev test clusters on demand, particularly for such parts of your system as the analytic systems. Doing DevOps for big data has its own set of challenges on top of what we're dealing with, the systems that don't have massive amounts of data. And we pretty much got to click a button, get yourself a Hadoop cluster deployed in a few minutes. Can you comment on how important that capability is to your organization?
Sure. I think it's just to comment on the project. The project has been, in my opinion, tremendously successful. It allowed us to do three things. It allowed us to basically deploy these test environments very quickly, and very quickly means truly with a push of a button, whereas before it would take cycles of basically doing the construction. It's that manufacturing pipeline. that Victoria referred to. So we basically streamlined that manufacturing pipeline to where we can bring up a cluster very quickly. The next thing is obviously that has cost implications, and so there are no people involved in bringing that up. And third, reliability. There are no people involved in basically reliably maintaining availability as long as the systems do what they're supposed to do. Well, that then goes back to the development folks. And what that allowed us to do is, in a short period of time, we were able to deploy a fairly large Hadoop cluster with fairly complex jobs running on it, and to take it to market essentially was a user-facing components to that running against that Hadoop cluster. And one thing to note is, if it weren't for this ability to dev test, essentially to bring up environments and test them, to iterate very quickly, this would have been much harder and would have taken much longer.
There is a talk today, I believe at 3:30. That's a joint talk with RingCentral, sort of doing a technical dive on how they do DevOps for big data on the cloud. Last question, Kira. Where do you see the next set of challenges and gaps? In particular, what are technology vendors not doing today? What you expect them to be able to do for you so that you continue to build that automation?
There are lots of gaps. So there's lots of things to do to enable companies like ours to be successful in streamlining this manufacturing process. And the reason it's so complex is, if you get to a size like ours, a sizable company with fairly complex products running on multiple platforms, and you're dealing with lots of unknowns. You're dealing with basically what I would call a configuration management problem. It's not just deployment, and people tend to simplify it and think, oh, if I could just deploy Chef and Puppet, then life will be great. Well, life will be great at some eventual state, but to get to that, it takes quite a bit of complexity and of gathering pieces that make up that final deployment step. And to date, I've seen companies just focus on that final deployment step and then monitoring of what happens after, but not really enabling development organizations to fully self-enable, to basically have that complete self-service environment, and to allow them to both test and deploy and essentially do that in a hands-free fashion and do that reliably. And I do mean building that conveyor. I don't necessarily want a lot of people in that conveyor. I want the button to be pushed at one place when the sprint is done, and during the sprint compilation, and that process to continue all the way to where it hits production environment with verification points, with ability to monitor that, with reporting. All be done essentially with self-service, with as few people as possible, because people are not only expensive, they're also error-prone, so we want to eliminate that as well. And I think that conveyor, I haven't seen yet that be done in the industry. I've seen different bits and pieces be addressed, but not that conveyor, which is what I'd like to have.
Well, thank you very much, Kira.
Thank you.
So let's take a look at what it takes to power those conveyors. The problem or the opportunity, or the mission, if you will, as I frame it, is to be able to have a complete computing system emerge in response of the business need. And that's a mission statement, if you will. That's a purpose statement. How do we get there? I want you to think a little bit about button makers and button users. Most people who are power users, developers, testers, release engineers, service engineers, sales engineers, support engineers, they know a lot about what it is that they do with the application. But they don't really know or need to know all the bits and pieces that make up that application, all the complex processes that have to be enabled and intact in order for application to be deployed or upgraded or scaled. So people who do know that, they are the mechanics, if you will. And you need very few mechanics, and you need lots and lots and lots of drivers. And so one of the things that we need to collectively do when we think about the role of the DevOps is not just write tools that can be used by the DevOps engineers themselves or by ops people or by the mechanics. We need self-service. We need to be able to take that complex automation and wrap it into extremely simple to use self-service interface. Now, what kind of buttons do we actually need? Well, there is a few that I call magic buttons. And I believe that every organization needs to build them, and every developers and tester and release engineer needs to have sort of a birthright to those 3 buttons. And the first button is launch. Launch creates a flashly minted instance of an application, essentially from nothing. Launch replaces IT tickets to create new development environment or a test cluster or a customer demo or a production instance. Launch should take only minutes to complete. It should produce fully constructed, ready to use, sort of a batteries included working instance of the application. It has to be loaded with data. It has to be connecting to the external services. It has to have everything in it. And as a part of constructing that environment, the provisioning of the infrastructure, the VMs, the Docker containers, the bits and bytes, they all sort of come together just in time. And we have clouds underneath that are allowing to do this. And we have configuration management systems like Chef and Puppets that are allowing to do allowing us to put the right bits to the right places. And we have a Docker containers coming in that allow packaging to be easier than we've ever had it in a VM-centric world. And yet all of these things, they have to be orchestrated, right? So that it happens at the right time, at the right moment, with the right stuff. Launch button provides that instant gratification. Launch button illuminates sequential processes as a bottlenecks. If you need to do smoke testing and regression testing and performance testing, sometimes it makes sense to do them sequentially, sometimes it doesn't. Go create 5 environments, one does regression testing, one does integration testing, all in parallel, all dynamically. It really liberates any team to have access to any environment at any time and manufacture these kinds of environments when they need and want them. So launch button is very, very cool. The second button that you must have as soon as you have launch, you have to create destroy. Environments cannot be allowed to sprawl uncontrollably. They cannot be allowed to stay up forever. And so the minute you figured out how to provision something, you have to sit down and figure out how do you actually deprovision it, particularly when you're using access to shared services, acquiring locks on resources that are used by other environments as well. Destroy button may not be as cool as launch, but it is absolutely vital. And it's interesting, I see a lot of systems with the customers who've made tremendous investments in automating deployment or provisioning, but not deprovisioning. It's like most of the environments are fire or forget, which is not how you do it in a controllable world. That's destroy. And then the third button, also very vital, is I generically call it reconfigure. But essentially what that does is that it gets the system in some kind of a state that it was there when you put it together to a new state. And systems change all the time. Probably by the time you completed your deployment, it's already obsolete. There is a new patch that came out of the network management team. There is a new API that came from a developers down the hall. There is a new release of some kind of a new component of the sister team that just broke component that I'm working on, right? So change is constant, and kind of the whole point of this agility with responsibility is being able to always bring existing systems into compliance with where they need to be today. One of the better known cases of reconfigure is upgrades, particularly production upgrades. People talk a lot about this, and they make it a special case, and often it is a case that needs to be treated specially. But it is all part of this, part and parcel of this bigger necessity of being able to take existing environment and bring it into compliance with the latest changes, or in fact roll it forward, roll it back, or get it to any known state that you want it to be in. There are some other buttons that you might want to manufacture. They are more or less extensions. The first three, if you implement them, give you a very, very solid foundation for the environment and application lifecycle management. You might want to create other shortcuts, things like patching, things like scaling, things like provisioning new tenant if you are a multi-tenant SaaS kind of a company. The word of caution, though, is that it's kind of tempting to make lots and lots and lots of buttons. And be very careful with it. It's better to have small number of well-tested and well-supported buttons that work than to have lots and lots and lots of buttons that in fact are sketchy and not very well tested and don't work particularly well. Because as Kira was saying here, what she needs is reliability. Automation without reliability does not work, does not meet the business needs. So Let's take a little bit closer look into this button making business, and we'll quickly discover an interesting level of complexity that I believe is at the core of the reason why automation today often fails to produce the kind of a business results that people want out of them. Essentially, we have this interesting plurality going on between a single application and the range of configuration that the application can take. When you're taking application, let's say it's some kind of, I don't know, search engine, and you are deploying it for development, and then you take the same application and you're deploying it to production, those are quite different configurations. You might use CentOS over here and Red Hat over there. You might use non-clustered technologies in development and clustered ones in production. You probably use a very small test databases on one side and massive customer production systems on the other. And how do you actually automate creation of two of these configurations? The predominant approach in the industry seems to be essentially fork and edit. So you start on the left, you write a bunch of, I don't know, Puppet scripts or Chef scripts that automate provisioning of Oracle and WebLogic, and then you create a button that allows you to invoke the scripts. Usually it's some kind of a Jenkins job. So a bunch of Jenkins jobs calling through scripts, bunch of Chef scripts, and you just got the thing to work on the left-hand side, and now you need to make it work in another environment. And what do? You fork, and then you go and you start making changes here and there. And pretty soon you have mountains of scripts that are calling mountains of scripts, which are copied and replicated in the versions that you can't really distinguish between. And you're creating nightmare of a maintenance for yourself. Now, is there a better way? We have an alternative design available to us. And that's essentially what I would call adaptive configuration. And that is to say that the same application that has been deployed for different purposes, and hence let me bring that notion of a person, why are you deploying it? Are you creating it for testing or regression testing or performance testing or staging or production or customer demo or what? Depending on the answer why you're doing this, you're going to end up with a different result. So the way to kind of get there is through policy. So you can introduce a notion of how do you actually codify a purpose. You can codify a purpose in a set of rules, let's call them policies. And then knowing what an application is and what it needs out of the environment, and then knowing what policies are active in that environment or for that purpose, you in fact can compute what a configuration is. Instead of, and in that case, there is no multiple scripts to write, no multiple application workflows to write, debug, edit, and support. The configuration emerges, again, based on the timing, based on the need, based on the context. To drive this point home, and I think it's a very, very critical point to make, I want to echo what Kira said here. She says something interesting. She said, we often talk about the deployment problems, but our problems are deeper, and I very strongly believe in it. And I think the industry too much talks about deployment problem, where in fact they have a configuration change management problem. Let me try to explain that. And the best way to think about it is to think about a printing press, a sort of original Gutenberg kind. What that press is brilliant at is printing many, many, many copies of the same thing, right? Copies of the same book. You can print 1,000, you can print 10,000. And that's what deployment systems really sort of inspiring to do. Press the button and print another instance of the application, which is all good and well until you start introducing one aspect, and this is the aspect of change. Now imagine the printing press that from a run to a run, the book can change a little bit. You know, not a whole lot. It's not a whole different book, but you need to fix a typo, add appendix, maybe add a reformat the footer. Well, what does that requirement does to a design of the printer? Well, it actually requires you to rethink almost everything about how that printer works. Now, make another change. What if paper can change from a run to a run? A little thicker, a little thinner, a little glossier, with more watermarks, different color, different lengths, different weight. And the paper can change at any point in time, and the book editions can change at any point in time. How do you construct a machine that can do that? Well, 5.5 centuries later, we get something like this. Modern industrial multi-purpose printer. Now, every facet of the machinery have been rethought, right? And that is exactly what essentially we are doing with our applications, with the exception of one more difference. Now let's introduce the notion that once these hundreds of books are printed and sold and in the customer hands, whenever there is a new edition of the book, we have to retrofit them all. We have to get every book that is out there actually in compliance with this latest version of the book. Well, we can't even fathom the machine that would be able to do that. We could start doing things like saying, okay, books have replaceable pages. And maybe we're going to start sending out the kits that says replace these 3 pages with these 3 pages, right? And send this to the customers. But not all changes are compatible, right? And if you need to replace 3 pages with 4, not only it's not going to stick neatly, but now you've sort of destroyed the numbering of every page. There's a relationship between cardinality of the pages and stuff printed on every one of them. And you change one, you must change the other. Well, in this case, you actually don't want a replacement kit. You want to replace the entire book, right? So if this was a frequent occurrence, a whole pricing of the books, distribution of the books would have to change. We would have a book replacement services, right? And they would have to cost optimize for delivery. Anyways, the point here is that is exactly what we are dealing with in the world of applications. And what is the right thing to do, whether we need to change an individual component when component changes, or in fact, the change configuration management is so hard that it is better to just decommission the previous environment, print the new one anew, and then just replace it. Those are very nuanced things that you can only understand if you understand the structure of the book, the structure of the page, the structure of the dependencies between them, and maintain that for every change and revision of every element of that structure. And if we kind of understand that, then our view of what it takes to create and maintain a live configured instance of an application becomes a lot more complicated thing, if you will, than executing script that somebody wrote once that executed a set of instructions. First of all, instance of a configuration, instance of application, it changes over time. And it's important to understand that tomorrow, same instance will look differently and behave differently than it did today. Now, what it is some kind of a function of what is the definition of an application at that point in time, what is the definition of environment at that time, and what was the set of policies that was applied in creating it. So I would argue is that building automation engines that are capable of that is what the next frontier of innovation is with respect to DevOps and with respect to automation management systems. Now, imagine for a second that that was a reality, that we had an automation engines that were capable of printing, essentially manufacturing instance of the applications just in time, on demand. what would that do to our overall productivity? So let's talk a little bit about the impact of being able to do that on the developers and the corporations that employ them all. The simple fact of today's state of the industry is that there is not enough developers to satisfy the needs in software development. Now, the Russian Minister of Communications recently went on record to say that if only Russia could triple the total number of developers available to them, they would solve all of their problems of dependence on the West for software production. Good luck with that, Mr. Nikiforov. On a more serious note, there is a body of objective evidence that shows the demand curve for the developers worldwide. By developers, I mean really technologists and engineers. And this is the fastest growing profession on the planet. We are going to see more people enter the profession. We are going to see more countries participate in the global marketplace, and it is still not going to be enough. So kind of the good news and the bad news. The good news for everybody in this room, you chose your field well. You will be increasingly more and more valuable to your organizations. The bad news is that problem is not solvable brute force. You cannot write twice as much software by hiring twice as many programmers. What you need to do is actually make the ones that you have twice more productive, and do that year over year over year. And that's the challenge that our entire industry has to deal with. With great powers come great responsibility, and that means that developers need to be able to do things a lot more efficiently. The expectation is that the timing, the learning curve to learn new languages, to learn new frameworks are dramatically shorter than they have ever been before. Time to value from creating a project team, assigning new people to that team and expecting them to be productive is dramatically shorter than it's ever been before. And developers are essentially expected to ship the code that works. Not bits and bytes that they throw over the wall and then sit and wait from QA, did it work? And from ops, did it actually work? The developers need to simply own more. And they need tools. And in order for that massive increasement in productivity to realize, the tooling have to become dramatically better what it is today. It's kind of moving from, I don't know, horse racing to Formula One or something. And actually, before sorry about this. Going back to the buttons and looking at developer productivity, what developers need more than anything is this access to stuff that they need. And only developer really knows what it is that he needs. So he needs these self-service buttons. He needs this ability to manufacture the lab environment that is running against his code, that is running against his tools, but essentially using the right elements of the system and running on the supported configurations. Now, why is this important for developer to have these personal private environments? I think it's a very important point. In order to make that point, I actually want to bring up another clip.
The key area we're focusing on is the following. Right now, if you buy a computer system and you want to solve one of your problems, we immediately throw a big problem right in the middle of you and your problem, which is learning how to use the computer. Right? Substantial problem to overcome. Once you overcome that, it's a phenomenal tool. But there is a barrier of having to overcome that problem. What we're trying to do, and I think there's a reasonable chance that Apple's going to make a real contribution to solving this problem in the next 36 months, is to remove that barrier so that someone can buy a computer system that knows nothing about it and directly attack their problem without learning how to program the computer. And the reason I think that Apple's got a chance of solving that problem versus a lot of other computer companies that we all know of that are much, much larger than we are now, although we're catching up, is that our whole company, our whole philosophical base is founded on one principle. And that one principle is that there's something very special and very historically different that takes place when you have one computer and one person. Very different than if you have 10 people in one computer.
So this was Steve Jobs in 1980, talking about why computers need to be personal. And I would reason that for the same fundamental reasons why two generations now, between 1980 and now, two generations of people have made personal computer the learning and creativity and productivity tool. It is exactly the same dynamics that is driving and will be driving the productivity of the automators, the productivity of the developers. There's something magical happens between developer having access to environment, not 10 people, not team having all access to one environment. That ability to experiment and say what if is only possible if the environment is personal. Now, since Steve spoke, computer notion expanded, right? It's no longer computers. Now we have environments. Now we have cloud. Software became services. So we have a lot more orchestrate. And it is no longer confined in a box. But that ability to manufacture that personal lab is a critical aspect of enabling that efficiency. Now, the second part of developer productivity is actually the industrial part. Once the code had been committed, now we're in agile factory space. Now we have to be able to apply automation to every aspect of testing, including the final delivery to the production environments. So in order for that to happen, the factory has kind of two parts that have to work together. One is the business workflows that define what pipeline is in terms of stages and approvals and exit criteria, and all the logistics of putting together environments that are accompanying every step of that conveyor belt. And to discuss again what this agile software factory and developer productivity means to another large company in another space, I would like to welcome Ratnikar Lavu, Executive Vice President of Digital Services at Kohl's.
Thank you, Victoria. I'm a little concerned that you're thinking about me as an elephant, but I'll let it go.
Well, give us some sense for just how big Kohl's is.
Well, so Kohl's has a tremendous amount of history. So we're 50 years, $18 billion. We've been doing software development for a while. So I head up all of digital technology that includes web, mobile, social, in-store experiences, and POS. So it's a great time to just talk about innovation, change, and how companies like us have to think differently. So prior to this, prior to this whole notion of CI/CD, the way we used to do kind of software delivery was we would have a roadmap, and we would decide on what we need to deliver that particular year. We would say, okay, we need about 5 test environments. We don't know whether they're really the right amount, but let's go with 5. Set up those test environments, and now start delivering software. Everybody would try to get into that test environment because they're so limited, and everybody would have contention in terms of changes and other things, and then it would create a tremendous amount of havoc in terms of delivery. And then only to find out that you didn't have enough test environments to begin with anyway. So that's the kind of this environment that we came from, and over the last 3 years, we've been really transforming the organization and into embracing CI/CD, this whole notion of dynamic provisioning. I love your slide about, it's not about just a set configuration. You need to actually start thinking about how that changes and dynamically change that configuration, and be able to do that in a way that is easy with a single click of a button.
So we've collaborated now for a couple of years to help instill that agility and create these self-service buttons that developers can use. So I know you're very passionate about developer productivity. So can you speak again in the business terms? What's the impact of a developer having that kind of control over its infrastructure?
Oh, absolutely. So for a big organization like ours, there's so many tentacles. Different systems, financial systems, kind of payment systems that we'll all have to connect to. The thing is, we cannot just get it right in terms of, build out a test environment and make sure that it works, and then, by the way, as you change, things will work. So what we found was, once you start doing this whole automation, in terms of how you think about environment provisioning, deployment, configuration management, and by the way, test data management and automated testing. Once you start thinking about that, we truly have the agility now to change things, understand what the impact is much before we ever did, because we only understood the impact of a change when we came into like a regression testing cycle or integration testing cycle, and then we went into production, and then you say, oh my God, what did we do? We created a disaster here. Now we understand that much earlier in the cycle. And the reason for that is, using automation, you can actually test how your changes are impacting other systems, as well as the experience for the customer. And then the developers have control to actually fix that much earlier in the cycle, which benefits us in terms of quality and delivery at the very end.
So what's next? Where is that frontier of what you are able to do, and you might have ongoing initiatives that capture the capabilities that exist today. But what is on your wish list? What do you wish technologies could do that it doesn't today and you expect it to?
Yeah, so in terms of the whole developer productivity, continuous integration and continuous delivery, I think we have gotten a lot better at Kohl's. Where we're still struggling with is the whole environment provisioning. Even today, companies that say they are in the, they're transitioning themselves into being a cloud company, I still have to cut a PO to secure gear in terms of the hardware to be able to do that. Companies should really think about this very differently. It is all about, I want to be able to spin up an environment. I want to be able to be charged for that environment as long as I'm using it, right? But I don't have to cut a PO. I don't have to do that anymore. I want to be able to spin that environment up. I want to be able to leverage my tools, the buttons that Victoria talked about, be able to deploy to that environment, and by the way, test it, certify it, and then move that, whatever I have certified, into production seamlessly. And that is still kind of in my wish list. We're going to get there probably in a couple of years, but that is still hard to do. And the vendor community has to really address this, because there are only certain companies that do this well, and then as companies think about being cloud providers, they have to really enable that for companies like us.
Well, very good. Radnikar, thank you so much.
Thank you.
So to summarize, I'd like to return where I started. There has to be a marriage of agility and reliability. There has to be a peace between cowboys and bureaucrats. To realize Steve's vision of our era, we have to be able to put the right tools in the hands of the right people at the right time when they need it. Companies across every industry is hard at work doing that. We have heard from Kira, we have heard from Ratnikar. They're leading their organizations through this transformation. The next frontier of innovation is building this for a DevOps community, is enabling construction of this conveyor belt and all facets within it. And it's a multidisciplinary function. The agile software development is a part of it, and the cloud that manufactures these resources on demand is a part of it. And application configuration, deployment, agility of the bits and bytes that come together in the right configuration at the right time is a part of it. And the testing strategy and the test automation is probably a fourth fundamental element of that. And the industry is making tremendous progress on all four fronts. Now they all need to get tied together, so it's a single conveyor belt that operates and ties together all facets of software, software construction, software testing, verification, and operations for companies who build and operate their online digital services. And if we get that, then we can have the right people focused on the button making and the right people focused on using the buttons to get their job done. And then the elephants will truly dance. Thank you very much.